think about the really intricate machines and setups out there, from big generators keeping the lights on to specialized engine systems. What's the one non-negotiable thing they all need?
Let me guess. Control.
Exactly. Rock solid control and, crucially, the ability to spot problems before they become, well, disasters.
Right.
Today, we're taking a deep dive into exactly that, the world of the DynaGen TUP series controllers.
That's right. We're looking at these pretty powerful pieces of kit. They're essentially the central intelligence for a whole range of generator applications and actually other systems too.
Okay.
We've been digging through the user manuals, the reference guides for quite a few models, like the Piro TDTE600A, the TE350, TE410, TG410, a whole lineup.
Okay, let's get straight to it then. For you, the listener, what's the big win here? Well, it's clarity. We're going to try and unpack what makes these controllers tick.
Yeah, strip away some of that dense technical language.
Right. Reveal what they actually do and how surprisingly adaptable they can be. Our goal is really to give you a solid grasp of their capabilities, how they're configured.
Our mission for this deep dive is pretty clear.
Yeah.
Pull out the essential understanding of how these controllers manage complex systems. We really want to highlight just how adaptable they are and the significant level of command they put in the user's hands.
So, boiling it down, what's the core purpose? What do these DynaGen TUF series controllers fundamentally handle?
Well, at their heart, they're engineered for comprehensive control over engine-driven systems. So that means vital protection features, handling AC power measurement, managing all the essential engine instrumentation.
Okay, the basics.
Exactly. But what's really noteworthy is they're designed for what the manuals call severe duty applications.
Severe duty, like what?
Think about generators on a busy construction site, maybe backup power units in demanding industrial settings. These controllers are built for environments where consistent reliability is just absolutely crucial.
Got it. So they're genuinely built for tough jobs. Now, how do you actually get one set up? How do you get it talking to the machinery it's supposed to control?
They give you a couple of ways. Pretty user-friendly, actually. You can navigate the settings right there using the buttons on the front panel of the controller itself.
Okay, direct interaction.
Or, for more detailed stuff, more advanced setups, there's the Rapid Core Configurator software. And, importantly, the docs mentioned this software is free.
Free software. Always good to hear.
Definitely. And that's where you can really, dive deep into the customization side of things.
Free and powerful, nice combination. So what are some of the key capabilities that make these controllers so effective?
Well, several features really stand out. They support the SAE J1939 CAN bus protocol.
CAN bus, okay. This is standard for engines now, right?
Pretty much. Think of it as a universal digital language that modern electronic engines use to talk to their control systems. This standard communication allows for really sophisticated control and diagnostics.
Makes sense.
They also offer multiple ways to keep tabs on the engine's RPM. You could use an older style magnetic pickup sensor, or they can analyze the generator's voltage waveform, use a dedicated touch signal, or, again, tap into that data stream via J1939 CAN bus.
So lots of options for speed sensing.
Very flexible. They also have built-in auto-start functionality essential for backup power, plus maintenance counters to help track servicing, and really detailed event logs. Those logs record the system's operational history.
Ah, those event logs sound like they could save a lot of headaches during troubleshooting.
They absolutely can be a lifesaver.
Now, about that tough name, is that just marketing spin, or are they genuinely built to handle rough conditions?
No, it seems to be a core design philosophy.
Yeah.
The manuals highlight features like conformal coating on the internal electronics.
Conformal coating, what's that do?
It's basically a protective layer, shields them from moisture, which is a huge deal in outdoor damp environments.
Right.
They also use gaskets to seal against water getting in. These are the kinds of details that really contribute to long-term reliability in those severe duty applications we mentioned.
Yeah.
So yeah, it's not just a name. It reflects the engineering.
Okay, that's good to know. So you've got this robust, feature-rich controller. What are the critical things to keep in mind when you're actually installing one? I imagine electrical safety is right at the top.
Without a doubt.
Yeah.
The manuals have very clear warnings. We're talking high voltages in generator systems. So they emphasize only qualified electricians should handle the wiring.
Absolutely. Not a DIY project.
Definitely not. Safety has to be the absolute top priority.
Makes perfect sense. Any other key safety advice they give?
Yeah, they outline several important general electrical safety measures. Things like thoroughly inspecting the work area first, keeping liquids well away from the equipment, ensuring proper grounding, super important, using the right fuses, supporting wires properly so there's no stress on connections.
Standard electrical best practices, basically.
Exactly. They also specifically mention fusing the power supply to the relay pack if you're using one of those optional relay expansion modules.
Okay. What about installing them in challenging environments, say places with a lot of electrical noise or maybe exposed to the elements?
They offer some practical advice there too.
Mm.
For noisy environments that might interfere with speed sensor signals, they recommend using twisted pair cables for the sensor wiring, run directly to the controller.
Twisted pair, right. Helps cancel out noise.
Precisely. And using isolated two-terminal sensors with twisted pair is also good practice for minimizing interference. For the physical installation in harsh conditions, they advise using vibration mounts, protects against mechanical shocks, and sealed enclosures for outdoor use to keep that water resistance intact.
Good practical tips.
These little details can really make a big difference in long-term performance.
Okay, so the controller's installed safely. Now, how does it actually connect and communicate with all the different parts of the system it's managing?
Right, this is where the versatility really shows. The TOFI series offers a whole array of connectivity options. Let's start with engine speed detection. That's fundamental.
Yeah, how does it know how fast the engine's running?
As we touched on, several methods. The traditional magnetic pickup handles a wide frequency range, sensing the AC waveform from the generator itself, using a dedicated tachometer signal. And of course, the J1939 CAN bus, getting speed data right from compatible electronic engines.
So it adapts to older tech and newer engines.
Exactly. Adapts to whatever the engine can provide.
Let's dive a bit deeper into that CAN bus communication then. It really seems like the standard for modern engine control.
It really is. When you're using J1939 over CAN with electronic engines, there are specific wiring things to keep in mind for reliable data transfer.
Like what?
The CAN bus network needs proper termination at both ends. You need 120 ohm resistors, and they need to handle at least 400 milliwatts of power dissipation.
Termination resistors, right, to stop signal reflections.
Exactly. They prevent signals bouncing back and garbling the communication.
Yeah.
Interestingly, some of the PRO series controllers actually have an internal terminating resistor you can just enable in the menu.
Oh, that's handy. Save some wiring hassle.
It really can.
What about other ways these controllers communicate beyond CAN bus?
Well, there's an RS-485 port available too,
Okay.
and that also features a software configurable internal 120 ohm terminating resistor.
Okay, similar convenience.
Yeah. For reliable RS-485, the manuals specify using shielded twisted pair cable, again with that 120 ohm characteristic impedance. They even point out not to use the shield drain wire as the RS-485 common ground.
Good detail.
They even give an example cable type. So RS-485 gives you another path for serial communication.
Okay, so RS-485 for another type of data link. And I also saw Modbus mentioned.
Yep. Modbus, another common protocol in industrial automation used for connecting various devices. The main user manual gives a high-level overview, but mentions that the real detail, the specific Modbus registers, the addresses for reading and writing data, is in a separate Modbus reference manual.
Available online, usually.
Yeah, on the Ketron website, they say. In the controller settings, you can enable or disable Modbus, set its device address 1 to 247, so you can have multiple devices on one network, and pick the communication speed, the baud rate.
Got it. And finally, something pretty standard these days, a USB port.
Exactly. There's a USB port on there. It's likely used for things like initial configuration, maybe software updates or diagnostics. The main manuals we looked at didn't go super deep on its functions, but it's that common interface for direct interaction during setup and maintenance.
All right, so the controller's wired up, it's communicating. How does a user actually interact with it day to day? How do they get the info they need?
The main way is usually the front panel. Typically just a few buttons, often just up and select to navigate the on-screen menus.
Simple interface.
Yeah. The system information menu is a really good place to start. It gives quick access to key details like hardware and software versions, model, serial number, any custom user ID or settings name you've given it.
Okay, identification stuff.
Right. Plus, crucial operational data like total engine running hours and maybe even hours left until the next service is due. Puts vital info right there.
That seems essential, especially the service counter. What about seeing what's happening right now with the engine and generator?
For that, they often have 4 customizable parameter display pages. You use that RabbitCore software to set these up.
Configure what you want to see.
Exactly. You can choose to display all sorts of real-time data. Engine speed, battery voltage, AC frequency, runtime, total engine hours, oil pressure, fuel level, coolant temp, whatever's most relevant.
Tailor it to the application.
Precisely. You
Yeah.
can even leave a parameter blank on a page if you don't need it constantly displayed.
Customizable dashboards, basically. Smart feature. What about when things aren't running smoothly? How does it alert you to problems?
Well, for those electronic engines using J1939, there's usually a dedicated DM1 page that shows any active diagnostic trouble codes, or DTCs.
So, immediate fault codes.
Right, tells you what the engine's computer's seeing right now. In addition to that, there's the events history log we mentioned earlier.
The troubleshooting lifesaver.
That's the one. It logs a whole range of events: power on, mode changes, manual starts, remote stops, emergency stops, and critically, any warnings or failures that have occurred.
And they're time-stamped.
Yes, crucially, each entry includes a timestamp. Invaluable for tracking down when an issue first popped up.
Absolutely vital for diagnostics. Okay, let's switch gears slightly. How does the controller actually take control? How does it operate the systems? Starting and stopping, for instance.
They're designed for multiple methods there. Often dedicated momentary switched inputs, simple start and stop buttons, essentially. Many also have a key switch start input.
Like a traditional ignition key?
Sort of mimics that, yeah. If you activate that input while it's in auto or off mode, it kicks off the start sequence, and the engine keeps running as long as that input stays active.
Okay. And what about more automated operation, like a generator kicking in automatically on power failure?
That's where the auto mode really shines. Some controllers have a neat pre-start feature the fuel relay can energize before cranking starts.
Why would you do that?
It lets the engine's ECM, the electronic control module, power up and be ready to go instantly when the starter engages. Helps with faster starts on electronic engines.
Ah, clever.
There's also a really useful battery recharge function. If the controller's in auto and sees the battery voltage dip below a set point,
It starts the engine just to charge the battery.
exactly, it runs it for a set period to top up the battery, making sure there's always enough juice for the next auto start. Really smart for maintaining readiness.
That is clever. What about shutdown? After the engine's run, does it just stop or is there a cooldown?
Good question. Many offer a configurable cooldown mode. After it gets the stop command, it can keep running for a preset time, usually at idle.
Why?
Lets temperatures come down gradually. Better for engine life, especially with turbos. Interestingly, the function of the front panel OFF button while the engine is running is often configurable too.
Configurable OFF button, how so?
You might set it to immediately start that cooldown cycle, or maybe perform a direct immediate shutdown, or even trigger a forced cooldown, where pressing it again does nothing until the cooldown finishes.
Wow, lots of options just for stopping.
Yeah, lets you tailor the shutdown process.
You learn something new every day. What about controlling engine speed? That seems really important for certain applications, maybe like pumping.
Absolutely. For things like pumping, where flow rate often ties directly to engine speed, these controllers frequently offer both manual and automatic speed control.
So you can set it or it adjusts itself.
Right. There might also be programmable speed limiting, to prevent overspeeding. For modern electronic engines, speed control can often be done right through J1939 Canvas. The controller just tells the engine's ECM what speed to run at.
Digital commands.
Yep. Some controllers even let you adjust speed manually from the front panel using the up-down buttons, or maybe via dedicated switched outputs wired to the ECM. Lots of flexibility there.
And I saw a specific mention of auto-starting on floats. That sounds very application-specific.
It is. It's designed specifically for managing liquid levels in tanks or reservoirs.
How does that work?
If you have a tank with float switches, either 1 or 2, you can set up the controller to automatically start the engine, which is usually driving a pump.
When the level gets low.
Exactly. Starts when it hits the low point, stops again when it rises back to the high point. It's a neat way to automate keeping a tank full or empty, depending on the setup.
That's an ingenious little feature for those systems. And what about process control? That sounds more advanced.
It is. That's a capability on some TE series models, firmware 1.91 or later, they mention. It's designed for precisely maintaining levels liquid or pressure by actively controlling the engine speed.
So closed-loop control.
Pretty much. 2 main methods. Main in, focusing on inflow control, and main out, controlling outflow. Again, it leverages that ability to adjust engine speed via J1939 based on sensor feedback for really fine-tuned regulation.
So these aren't just simple on-off boxes. They can do quite sophisticated process management. Now, a critical part of any system is monitoring its health and having protections. What kinds of sensors can these work with?
They're designed for a wide variety. Low and high resistance sensors common for temp and pressure. They also support universal sensors.
Universal, what do those take?
Resistance, voltage, or current inputs. Offers even more flexibility. You configure these inputs for things like engine temp, oil pressure, fuel level. Plus, many models let you add up to 4 auxiliary sensors for monitoring other custom parameters specific to your needs.
Good range of sensor compatibility then. Comprehensive monitoring. What about the electrical side, particularly with generators? AC power monitoring.
Oh yeah, extensive AC monitor capabilities. Protects the generator and whatever it's powering. You can configure it for different generator wiring setups. 2-wire single phase, various 3-wire types, 4-wire 3-phase, delta.
Covers most common setups.
Right. Some models even have an auto selection feature to detect the wiring automatically. The controller constantly watches the output voltage and frequency.
And you can set limits.
Exactly. Precise upper and lower thresholds for both voltage and frequency. If things go outside those limits, it can trigger warnings or initiate a shutdown to prevent damage.
Built-in electrical protection. Good. What are some specific warnings and failures it looks for?
The list is pretty comprehensive, covers common stuff like low or high battery voltage, low coolant level, loss of communication with the engine ECM, engine stall, low or high fuel level, under or over frequency from the generator, breaker tripped or failed.
So the usual suspects.
Pretty much.
Yeah.
But importantly, it also allows for a number of configurable warnings and failures. So you can set up custom alerts and shutdowns based on parameters critical for your specific application.
That customizability sounds really valuable. I also saw something called battle mode. Sounds intense?
Yeah, it does sound dramatic. Battle mode is an interesting kind of specialized feature. You activate it via a dedicated switched input.
And what does it do?
When it's active, the controller essentially ignores all incoming warnings and failures.
Ignores them. That sounds risky.
It is, but here's the crucial part. Any failures that do occur while in battle mode are latched. They're remembered.
Okay.
So as soon as you exit battle mode, if there are any latched failures, the controller immediately initiates a shutdown.
Ah, I see. So it's a temporary override for critical moments, but with a safety net.
Exactly. For very specific situations where you absolutely must keep running for a short period despite problems, but it ensures a safe shutdown afterwards if something serious happened.
Interesting feature. And of course, the most fundamental safety feature, emergency stop.
Absolutely essential. An external e-stop switch is mandatory. It has to be wired to directly cut the fuel or ignition supply. Provides that immediate, reliable shutdown for emergencies.
Okay, makes sense. We've covered real-time operation, immediate protection. What about time-dependent functions? Timers, scheduling.
Yep, they have several types of timers. Engine logic timers manage the start-stop sequence steps.
Like what?
Things like a delay to start after the signal, preheat time for diesels, crank time duration, crank rest time between attempts, energize to stop time for certain engines, and that cooldown timer we talked about.
Fine control over the sequence.
Right. There are also settings for handling things like false restarts engine fires briefly, then stalls and false checks to avoid misinterpreting brief glitches.
Those false start settings sound useful, prevent nuisance stops. What about more proactive scheduled stuff?
They include an exerciser function, lets you schedule automatic engine exercise periods.
For standby generators.
Exactly. Typically set up maybe 16 weekly events, configurable start time and run duration. Keep standby units tested and ready. There's also a long time run feature, set a duration for the engine to run after a trigger, like a manual start. And finally, a maintenance timer.
Counts down to service?
Yep, counts down the time, triggers alerts when the next scheduled maintenance interval is getting close.
So from the immediate start sequence right through to long-term maintenance scheduling, lots of time-based control. Now, for users who really want to fine-tune things, get into advanced functions, what customization is available?
This is where that Rapid Core Configurator software really comes into its own. It unlocks advanced options. You can't always get through the front panel,
Like what?
like fully customizing those 4 parameter display pages we mentioned. You can even create custom diagnostic trouble code messages for more specific fault identification.
Custom fault codes, interesting.
Yeah. The controllers also have configurable switched inputs and outputs. You assign functions, active states, control external things like fuel solenoids, starters, alarms. For security, there's often passcode protection to stop unauthorized setting changes.
Security is important. What about tweaking sensor readings or handling odd voltages?
They often include a trim or offset feature, lets you calibrate sensor readings for better accuracy, and if you need to measure higher voltages than the controller can handle directly.
Like over 30 volts or something?
Yeah, the manuals sometimes show example circuits using a voltage divider to safely scale the voltage down to a measurable level. And to get more high current outputs, there's often support for that optional relay pack module adds extra slave relays.
Sounds like they've thought through quite a few integration challenges. What about specifics for certain engines or communication systems, J1939 specifics?
They frequently have features tailored for J1939 Canvas. Things like auto-address negotiation helps avoid address conflicts on the network. Often specific support for certain engine makes, like Cummins G drive or options for Volvo EMS2B systems.
Manufacturer-specific support.
Right. Some models might offer ambient air temp control via Canvas. Users can often manually request DM2 codes, the more detailed fault codes, with a button press. And for modern engines, with DEFSCR emission systems.
The exhaust fluid systems.
Yeah, the controllers can offer monitoring and control functions for those too. Finally, DynaGen has its own proprietary PGN's parameter group numbers within J1939. Allows broadcasting specific data and remote control of the controller itself over the network.
Wow, really deep integration with J1939 and specific engine tech. And for people using Modbus, what kind of data can they get remotely?
That separate Modbus reference manual lists all the registers. You can read data to monitor or write data for remote control.
What kind of things?
A wide range. Remotely send start-stop commands, read real-time engine speed, temp, pressure, fuel level, generator frequency, voltage, current. Get the current operating state, active warnings, events, the maintenance counter value, lots more. It's a powerful interface for remote integration.
Significant remote monitoring and control via Modbus then. Okay, to kind of pull all this together, can we look at a few real-world examples? How are these features actually used?
Certainly. We touched on pumping applications already, manual and auto-speed control, auto-start based on float levels.
Right.
The manuals also mention use in wind machine applications, maybe using transducer inputs for control there. And of course, generator systems are a prime application, using all those AC monitoring and protection features.
They really do seem versatile.
Absolutely. The DynaGen Tough series provides a really robust, highly configurable solution for managing, well, a whole array of engine-driven equipment.
Yeah.
The depth of customization, combined with integrating multiple communication protocols, it's genuinely impressive.
And for you, the listener, the key takeaway here is really the remarkable level of precise management and monitoring these controllers enable. That kind of granular control ultimately helps prevent costly downtime, helps optimize performance of critical systems.
Yeah.
The real aha moments, I think, come when you see how all these different settings and functions connect, how they work together to provide this comprehensive, adaptable control solution.
And that raises a really interesting point to ponder. With this level of, intricate control over complex machinery, what new levels of efficiency or automation actually become possible?
Good question.
And what other, maybe less obvious applications beyond the usual generators and pumps might really benefit from this kind of intelligent control technology? It's worth thinking about the broader possibilities.
Some really fascinating questions there. For those of you listening who want to dive even deeper, maybe you're considering using these controllers. We definitely encourage exploring the DynaGen documentation and that rapid core software.
For sure.
You can find a wealth of resources, technical support info, all that at www.gatron.com.
It's definitely a deep well of technical knowledge there if you need it.